Hello friends, welcome to Power Electronics. Today we will discuss the single phase semiconverter. In a single phase semiconverter, we have two thyristors, that is T1 and T2, with the three diodes D1, D2 and a freewheeling diode. Load is RLE type, and what we have taken the assumption that load current is continuous. So if you look at the diagram here, Vs is the source voltage. So how the current starts flowing? As the supply voltage Vs is positive, so current Is flows through the thyristor T1, and then it goes to the load RL and to the back path through the diode and then to the back path. This is the direction of current. So here the thyristor T1 and diode D1 starts conducting. When the supply gets reversed, how it gets completely changed. Now when the supply changes, here it is plus, here it is minus, the current flows through this path, T2 starts conducting, current flows through the load RLE and through the diode D2 and current reaches the back path. So here the thyristor T2 and the diode D2 starts conducting. But in between there is also a freewheeling diode. So freewheeling diode will also conduct. I will explain this in detail. So this is the source voltage, that Vs. This is the source voltage, rises, then it falls, rises and then it falls. Its name is VAB. If we take the dotted line, it is VBA. So if you look at the source voltage, that is Vs, and we look at the same time the output voltage, after a firing angle delay of alpha, we triggered it. We have observed that the output waveform is same as the source voltage with the angle delay, that is alpha. Same you can observe here also, it is V naught. Also we have taken the assumption that load current is continuous. So here the thyristor T1 and D1 was conducting in the positive supply. So thyristor T1 here and diode D1 is conducting. So you can see that here it rises here and reaches a point at a pi, at the instant pi. After the supply reverses, before the supply reverses, the thyristor here the inductor gets here dropped with the resistor and the battery E. The Vm sin alpha, that is our source voltage, should be greater than the E. Otherwise the no current will flow through the circuit. So here we have to remember this. Also the inductor is charged with the polarity plus minus. In the negative half cycle, it becomes plus minus. So it starts discharging through the freewheeling diode. So you can see that here at the instant pi plus, at the instant pi plus, the this freewheeling diode starts conducting. Again with the negative supply, here it becomes negative and here it becomes positive. So what happened here? The current starts flowing from this to the thyristor T2, then it goes to RLE and the diode D2. So that means here T2 and D2 starts conducting. Again at this particular instant, the freewheeling diode again starts conducting. Again the same process repeats. Here the thyristor T1 and D1 are conducting. The load current shifts to freewheeling diode. As you can see, the load current shifts to freewheeling diode. Also when the T2 and D2 conducts, again it shifts to freewheeling diode. Also if we look at the condition of thyristor, IT1 current through the thyristor T1. So here the current flows through thyristor T1. So it starts conducting here from instant alpha to pi. So what is the conduction period of it? It is pi minus alpha. Also you can see here that during the negative half cycle, the thyristor is not conducting. It acts as an open circuit. So it is the current in the thyristor is 0. Also we can see here it rises and then it falls. The conduction period is pi minus alpha. The same repeats again. Also if we look at the freewheeling diode always conduct the instant pi. Here it conducts at the instant pi and pi plus alpha. So you can see that it conducts here only. Same with each step. Also you can see that the source current is same as the thyristor IT1. It rises and then it falls to at the instant pi. Same again it repeats, but the supply here changes, load current shifts, so you can see it is negative. Again you can see the source current rises, then it falls and reaches at this point. Here the dotted line, I mark it. This is the dotted line here. It shows that here the freewheeling diode was conducting. So the source current is rising and then it is falling. Voltage across the thyristor T1. If you look at the thyristor T1 here, so what happens? The thyristor was conducting in the positive half cycle. So it acts as a short. So that is why there is no voltage across the thyristor. Also from pi plus alpha the freewheeling diode was conducting. Now what is the voltage across the thyristor T2? If you look at the thyristor T2, when the thyristor T1 was conducting, it acts like an open circuit. So Vs is the voltage across the thyristor T2, but it is negative voltage. So that is why it is minus of Vm. Same again, it acts as a short and the voltage across it is minus Vm. Also you can see in the thyristor V2 that when the this thyristor T2, when this thyristor T2 is short, that means it voltage across it is 0. If you look at the voltage across the thyristor T1 at that particular time, it acts as an open circuit. So it has the minus Vm. You can see here it is minus Vm. So this is the explanation of the graph. Also one thing we have to remember that only the supply current will flow through the load when Vm sin alpha, that is source voltage, exceeds the this battery EMF E. This is DC. You can say that it is a DC or DC battery. So we should remember this. Also you can calculate the output value. So this output, how we calculate? We calculate it by area upon time period. So we know that 1 upon pi ranges from alpha to pi. The thyristor was conducting from alpha to pi. So this is the source voltage. So what we get the output voltage? Vm pi 1 plus cos alpha. Also you can see the RMS value, root mean, square value. Square it, take mean and then take its root. So this is the value we get. RMS value equal to Vs 1 by pi minus alpha sine to alpha upon 2 under root. So this is the way how the single